had to restart.
I did have to restart.
You had to restart.
Okay. So a parallelogram.
How many times do you record a lesson?
With 4 right angles. Okay, so that is what a rectangle is, a parallelogram with 4 right angles. Since a rectangle is a parallelogram, it also inherits all of the traits that we've talked about with parallelograms. So all 4 angles are right angles. Duh, because that's what we just said. So we have all of these are right angles. Okay. What's true about opposite sides?
They're equal to each other.
They're congruent and what?
Linear.
Mm.
I'm just kidding.
It's a parallelogram. So they're parallel. Good, guys.
Sorry, guys. We're kind of slow.
Parallel and congruent. Okay, so that means these two are the same length, and these two are the same length, but also this is parallel to this side, and this side is parallel to this side.
Does it matter which way the arrows are?
Ooh, why did it do that? Why? Oh. Sometimes it does that, and I don't know why it does it sometimes and then not other times. That was weird. Okay. Strange.
Does it matter where the arrows are pointing?
No. Just as long as they're both pointing the same direction, though. Yes. Okay. So, what is true about opposite angles? Yeah. Opposite angles are what? Congruent. So that means this angle is congruent to this angle, and this angle is congruent to this angle. But what's also true about rectangles? Are all angles congruent? Yeah, because they're all right. So while it does hold that property, they are all technically congruent. What's true about consecutive angles? They are supplementary. They equal what? 180. Which is also true because 2 right angles.
You said 190?
What?
Say
I said 180.
Oh, sorry.
Well, we have it recorded, so maybe I can go back and check. It should be 180.
You said 180.
Okay. And then what's also true about diagonals?
Intersect.
They do what?
Intersect.
Not intersect.
Cross.
Bisect.
Hey, I was close.
Okay, meaning if I have a oh, that was a rough looking diagonal. I'm gonna try to fix that one.
Ooh.
She was rough. I'm gonna get a ruler because God knows I need it.
Not Miss Hubbard's cheating with a ruler. Miss Hubbard's cheating with a ruler.
I am.
Wow. Our teacher is a cheater.
You can use your ID. Okay, and so these diagonals are bisecting each other, meaning this piece is congruent to this piece, and this piece is congruent to this piece. Do we understand that? So, another theorem specifically about this is if a parallelogram is a rectangle, then its diagonals are also congruent. Okay, so the true statement about this is that it actually means these diagonals are congruent to one another as well.
By any chance, could you pause right here? I can't write that fast.
Yeah, I can pause for a sec. Get on my level.
That's so random.
Huh?
She said she couldn't write that fast. She has to get on my level.
Okay, I'm done.
Okay, the converse is also true. What would the converse be? If the diagonals Of a what? Parallelogram are what? Congruent. Then what?
Then it is a rectangle.
It's a rectangle.
Oh no, not back with this if and then.
We got one.
You keep forgetting your little apostrophe in the it's. I'm grammar policing right now. It bugs me. Thank you.
Can I go? Okay. So we have quadrilateral JKLM is a rectangle. If the measure of angle KJL is 2x plus 4, and the measure of angle JLK is 7x plus 5, find x. Okay, so let's write that down. So we have JKL. What's this one? This whole thing is 2x plus 4. I'm sorry, I wrote that wrong. Nobody stopped me. Why did no one stop me? Sorry, KJL is 2x plus 4.
You got this one right.
Nobody stopped me. And KLJ, this one, is 7x plus 5.
Do you have JKL? Wait, that's not even.
No. But what is JKL? If this is a rectangle.
360. Wait, what's the question?
What is JKL if this is a rectangle?
Right triangle. Right triangle.
Girl, the angle JKL.
Oh, 90.
90.
Oh, thank God. Okay.
Trying to figure out what you were meaning.
It's 90, so then I have a triangle, and what do the three angles of a triangle add to?
180. Sorry.
180.
Sorry,
Okay.
sorry.
Whew. Okay,
We're all
so
struggling
Long day
today.
recovery.
then I can take that 90, and I can add 2x plus 4, and I can add 7x plus 5, yes?
That's 7x plus 5.
Yes. And what does that equal? 180. Okay. So I can combine my x's, so I'm going to get 9x, and I can combine my constants, so that's going to give me 99 equals 180. Then what do I do?
Subtract 99.
Subtract 99. Oh. So 9x equals 81. And then we divide by 9. So what does x equal? 9. Can I stop there? Yes or no?
Yes.
Yes, it asked me for x. I found x. Okay. Alrighty. So the next one says JP. That's, I'm gonna erase. Is it okay if I erase this? Okay, just so you can see it a little better. Tells me that JP, that's this piece, is 3y minus 5. And that MK,
I can't write.
that's this whole thing, is 5y minus 2.
Oh, I'm so retarded.
Don't say that.
Okay.
It makes a Y.
Yeah.
Which is really funny because we're supposed to find Y. Oh my gosh, I'm so sorry.
I can't post this video. Okay. So if that equals JP, what do I need to do here? What do I know about these diagonals? They bisect each other. So that means this one is going to be congruent to this one, yes? Okay, so that means that this would also be like 3y minus 5, yeah? Okay. And what's also true about the diagonals in a rectangle? They're congruent, right? So I can say that 5y minus 2, that's that whole diagonal MK, is going to be equal to 2 times 3y minus 5. Do we see that? Okay. So I'm going to get that 5y minus 2 equals 2 times 3y, which is 6y, and 2 times negative 5, which is negative 10. I'll subtract 5y from both sides and add 10. So I'm going to get that y equals 8. Are we okay with how I set that up?
You should keep the video just for like future things when you need a laugh or something.
Okay. Can I go? Okay. So let's do the next one. So this says ZXW. So ZXW, that's this one, is x minus 11. Actually, you guys try this one on your own.
You were so close.
Nope, you guys do this one on your own.
Is this one?
Where are you back?
Is the syllabus posted under your classroom? Because I need it.
Yes. Yes, it is. It's under class information. Mm-hmm. No, I'm still going to use this video. I'm just going to cut a bunch of stuff out.
Can you scroll it back to the top? I can tell when you're like gonna put in your ed puzzle questions. I can tell. Like, do this by yourself.
Yeah.
That's when you put one in.
Yes, you have to do this by yourself. Why are we doing this by ourselves?
I'm thinking.
Are you thinking with your phone?
Yeah.
Okay.
The guy in the bathroom is open. What about you? I have no idea. Well, I had a brace, and then it didn't work. I don't even know, something like that. It was really slow. I'd rather this in the brain.
Okay.
Finish off.
My fingers.
Those are example drawings.
That or paper.
I'm sorry, Kirby.
I got what she got.
Okay.
So I guess it's right.
Okay.
11 minus 9. What's that? That's 2, right? That's 2. That's 2.
I didn't listen to the whole album because I didn't listen to it. Yeah.
Can you go on the part 8?
Yeah. What do we get?
Struggle.
Exercise.
55.
Okay.
So ZXW, that's talking about this angle, we found out is x minus 11. And then we got WZX, that's referring to this angle, that is x minus 9. So again, we're forming a triangle there. Do we see that?
Yeah.
So we do x minus 9 plus x minus 11 plus 90 equals 180. So we'd get 2x plus 70 equals 180. We'd subtract 70 from both sides, and we get that 2x equals 110. And then we divide by 2, and we get that x equals 55. But am I done?
Nope.
No, y.
So you gotta find measure.
Yeah, it asked me for the measure of angle ZXW, so I need to plug that back in. So I would say 55 minus 11, and so we should get that it's 44 degrees.
Miss Hubbard.
Yeah.
I just put the two things equal to 90.
You can also do that. Okay, can I go? Alrighty. So we are trying to figure out, we're going to do some more with the distance formula today because y'all seem to struggle with that a little bit on your homework. Okay. So quadrilateral PQRS has vertices P, Q, R, and S. It's graphed here. We want to determine whether this is a rectangle by using the distance formula. So let's start. What is the distance formula?
That's gonna be
Square root
then
x2 minus
x2 minus x1 squared plus y2 minus y1 squared.
y2 minus y1 squared. Very good.
I'm so sorry. We should add parentheses around that for Kyler.
It would have been wrong.
Okay. So in order to prove whether it's a parallelogram, this is what we did last class. What do I need to prove?
That some things are
What specifically? Opposite sides are congruent. Okay. So let's first start by finding the distance of PQ. So I'm going to call this x1, y1, and this x2, y2.
You ain't gonna erase these every single time, are you?
I'm going to erase the ones that I put up here. Yes. Okay. So I'm doing x2, which is 1, minus x1, which is negative 5 squared, plus y2, which is negative 1, minus y1, which is 3 squared. What's going to happen to that double negative? Positive. So I'm really doing 6 squared plus negative 4 squared. What is 6 squared? 36. And what is 4 squared? Negative 4 squared? 16. So this is going to be the square root of what?
Yeah.
52.
I was getting there. You just got there before me.
Does anybody remember what 52 simplifies to?
No. Like the number outside of the thing. Wait, I got
It's just
you.
one of the 50 and
5.
2. Wait, no, that's
No.
wrong.
It's
So basically,
I really want to get it right.
13.
52.
What?
14,
Close.
12?
18.
Further away. You guys are getting worse.
18. It's 18.
13? Wait, 15? 14?
Oh my god.
How close
It might
was
be
I?
13.
It's, oh.
2 root 13.
Oh, okay, I was close. Okay.
We look at the, if we don't remember, we look at the highest perfect square. 52 is divisible by, that would be 4. And it's 4 times 13. What's the square root of
I
4?
remember doing those. Those suck.
We did those at the beginning of the year.
Yeah, I know. And I basically failed that one.
Well, next thing I need to find is what? RS. So this we'll call x1, y1, and x2, y2. So let's find that. So we're going to do x2, which is negative 7, minus x1, which is negative 1, squared, plus y2, which is 0, minus y1, which is a negative 4 squared. And again, those double negatives are going to go positive. So we're doing negative 6 squared plus 4 squared. So negative 6 squared is what? 36. And again, 4 squared is going to be 16. So again, we're getting the square root of 52, which simplifies to what? 2 root 13. So are these congruent?
Yes.
Yes, they are. Okay.
Wait, so if they weren't congruent, you would have to keep going?
No, if they weren't congruent, you could stop because it's not going to be a parallelogram.
Oh.
Okay. So we know that these two are congruent. So now let's find the other two sides. So now I need to find the length of what? PS and R cube. So I'll start with PS. I'll call this x1, y1, and x2, y2. Be the square root of -7 minus -5 squared plus 0 minus 3 squared. So again, those double negatives are going to do what?
Cancel out.
Cancel out. Go positive. So we're going to get -2 squared plus a -3 squared. What is -2 squared? 4. And -3 squared is 9. So this is going to be the square root of 13. Does that simplify? It doesn't. Okay. And lastly for this, I need to figure out, is it what that last side, so that QR. Okay, so I'm going to do x2, which is -1, minus x1, which is 1, squared, plus y2, which is -4, minus y1, which is -1. Those double negatives go positive.
No, -1 minus 1.
So I'm going to get -2 squared and a -3 squared. So again, I'm going to get 4 plus 9, which is again the square root of 13.
Is there a simpler method to do it?
Nope. So is this congruent?
Yes.
Yes. Okay. So we got that this side is congruent to this side, yeah? So that tells us, is this a parallelogram?
Yup.
Yes. And that is because PQ is congruent to RS and PS is congruent to QR. Okay? So we just proved that it's a parallelogram, but now we want to prove and see that it's a rectangle. Are all parallelograms rectangles? No. And so we're still using the distance formula. So what is congruent that is going to make something a rectangle? The what's? Well, both sides are congruent, but
I mean, every side.
yeah, but we're using the distance formula. Can distance formula prove right angles? No.
I don't know how to explain it. Not
Probably
every
don't
side
know what
can
it
be
is.
congruent.
No. What has to be congruent in order to prove something is a rectangle?
Diagonals?
The diagonals, right? Yes? No? Because back here we said a parallelogram is a rectangle when the diagonals are congruent. Okay? So now we want to see if the diagonals are congruent. Okay, so we're trying to find the distance of the diagonals now. Okay, so first I'm going to find what? PR. So I'll call this x1, y1, and this x2, y2. P. So I'm doing -1 minus -5 squared plus -4 minus 3 squared. So double negative will go positive. So I'm really getting 4 squared plus what? -7 squared. What is 4 squared? And what is 7 squared? 49.
Which equals, let me get it, 65.
Very good. And I'll tell you that one doesn't simplify, right? Because we can't really divide by 2. You can divide by 5, but it's not giving you something that's pretty. Okay? So now what do I need to find?
QS.
SQ or QS? Either way. So I would say y2, which is negative 7, minus y1, x2, which is negative 7, minus x1, which is 1, squared, plus y2, which is 0, minus y1, which is negative 1, squared. So negative 7 minus 1 is going to give me negative 8 squared. And again, this double negative will go positive, so I'll get plus 1 squared. What is negative 8 squared? 64. And what is 1 squared? 1. So are these congruent? Yes. And so is it a rectangle? Yes, because we can say PR is congruent to QS, or the diagonals are congruent, or something like that. Okay? And so that's how we would find it with the distance formula. We did the distance formula a lot.
What's the midpoint? Is the x2 minus x1 divided by
x1 plus x2 divided by 2.
Oh.
That's the midpoint. Okay, but the next one is asking us to do the slope. So this one didn't graph it for us, so we are going to go ahead and graph it. Do you guys see the axes there? Okay.
The what?
The axes. The x and the y axes.
Axis plural.
What do we call it?
Okay, so we're going to plot our points. Okay, so we're plotting negative 10. Oh, God. 1, 2, 3, 4.
Bottom of the page.
Nope. Negative 10, 2 is here.
Oh.
The bottom of the page.
Okay. Negative 8, negative 6. It's here. So this is J. This is K. L is 5, negative 3. So this is L. And M is 2, 5.
2, 5.
Mm-hmm.
Okay. Is he right?
Okay. What is the slope formula? Y2 minus, what is the slope formula? Y2 minus Y1 over X2 minus X1. So to prove it's a parallelogram using the slope formula, we're trying to see if opposite sides are what? Not congruent, parallel, right? So first I'm going to need to find the slope of, let's do JM. Actually, let's do JK because it's in order. Okay. So we'll call this X1, Y1 and X2, Y2. So we'll say negative 6 minus 2 over negative 8 minus negative 10. Again, double negatives will go positive. So we'll get negative 8 over a positive 2. So what is that going to be?
Negative 4.
Negative 4. Mm-hmm. And I want to compare that to what other slope? LM. So I'll call this X1, Y1 and this X2, Y2. So I'm going to do 5 minus negative 3 over 2 minus 5. So what am I going to get? Negative 3. Is that negative 4?
No.
No. So is this a parallelogram?
Nope.
No. because JK is not parallel to LM. What else could we do? If we graphed it, how else could we find that graphically? Starts with an R.
Rise over run.
We could also do rise over run, right? One thing I want to mention. So if we're trying to prove it's a parallelogram, we're looking for opposite sides to have the same slope. Yes? What if I'm trying to prove that it's a rectangle? I would want adjacent sides to have what slope? Opposite reciprocal, right? I want them to be perpendicular because perpendicular means they'd meet at a what? At a right angle. So we'd want adjacent sides to be perpendicular. So we want an opposite reciprocal slope. Okay. Do we all understand that? So if on your homework it asks you, okay, is it a rectangle? Then you would have to do the opposite reciprocal slope. And see. But you would have already found the slopes from step 1, so you would just check it. Does that make sense? Okay. And last but not least, I know you missed them. It's time for our proof. Yay! Woo! Woohoo!
You were too enthusiastic about this, Miss Hubbard.
Let's do it. Okay.
She just wants to see the tears.
Right.
And she will.
She wants to see me cry.
Statements and reasons.
I'm so excited. Like, you've been waiting for this day.
I'm gonna fail till end of the year exam.
You are so dramatic.
If you put your grade up all year, to the end of the year, exams can't do that much damage.
Okay.
Because I failed my math exam 1 year and I still had a B.
You know she's.
I am still
Sorry.
recording.
You can edit that out.
I'm going to have to do a lot of editing, I hear.
Wow.
You might want to edit out that call.
What's my first reason?
Given.
Given. Woo!
I hate everything.
Man.
AC.
Rectangles.
The AC.
Don't. Well, like this, I know, like math.
Okay. I also, can we pretend that these little congruent pieces aren't here?
Yeah.
They are meant to be there. Sorry. Okay. So we have that. We're trying to prove that triangle ABC is congruent to triangle EDC. Okay, so we're given one piece is congruent. What other side could we say is congruent? A.
E.
Would that help us? We're trying to prove these two triangles are congruent. AB is congruent to ED.
Oh, yeah.
Why?
Opposite sides are parallel.
Opposite sides are congruent.
Yeah.
Right? So you could say like definition of rectangle or definition of parallelogram. I'm going to say definition of rectangle because it is a parallelogram. Okay.
I wish
So that gives us that these two are congruent. What else does the fact that it's a rectangle tell us?
that AE and BD are congruent.
So it tells us stuff about the diagonals, but are diagonals really in this picture?
No,
No.
that AE and BD are congruent.
Yeah, but that doesn't really help us to solve for these two triangles.
Oh, we're supposed to solve for triangles. Okay.
What?
Prove ABC.
No, it doesn't tell us that BC and CD are congruent because it doesn't say it's like a midpoint, right?
ABC and CDD are and CDC are right angles. Wait, really?
Yeah, this is a rectangle, guys. So do we understand that these would be right angles?
Yes.
You did not say that.
So we can
What about
say
the angles?
angle B and angle D are right angles. Definition of Not right angles.
Rect.
Rectangle again, right? Because rectangles have 4 right angles. So do I have enough to prove?
Yes.
I do. So I could say triangle
That's gonna be
ABC
rectangle or rectangle.
Side
rectangle.
Side, yes. Yeah. Side angle.
No.
Side angle side.
Nope.
Side angle side. Is
No,
that
it's
what
angle side side.
Nope.
No,
Is
but
it
like that's
any
what-
of those?
That's like if
That-
you were
Is
to
it
do
any
that.
of Is it any of those? Oh my gosh.
It's a right triangle. Hypotenuse leg.
Oh my God.
I got it right now.
Did you, Chris?
Yes.
Did you?
I
Fun
told
fact,
you the answer.
Nobody asked. I'm sorry, that's me.
Don't be mean to Carissa.
I know we're longer than you.
So,
Gotta give you the right.
to be mean?
To her, a little bit, yeah.
Why are you forcing it?
Okay.
You're
Do we
rude.
understand that? Yes? So it'd be hypotenuse leg.
So much editing.
All right. That is a lesson for today.
Yeah.